Topic 10, circles. So let's start with the equations of a circle. This right here is on your formula sheet. It would be on the back or page 2, depending on whether you're looking at a paper version or the digital version. H and K are your center, and then R stands for your radius. The most important thing to remember is that because there's these minus signs in the formula, H and K are always going to be the opposite of what they look like. So if we're given x plus 6 squared plus y minus 1 squared equals 196, the center is going to be the opposite of these two things, so negative 6 and positive 1. The 196 here on the end is r squared. So r squared equals 196. To find the radius, we would have to square root both sides, which gives us that we have a radius of 14. And remember, our radius is halfway. Diameter is the entire way across, so it would be 14 times 2, which is 28.
Example number 2. The center of a circle lies on the point 5, negative 6. If the radius of the circle is 14, does negative 9, negative 6 lie on the circle? So the first thing we need to do is write our equation for the circle. Since this is the center, this would be H and K, and 14 would be R. So x minus 5 squared plus y plus 6 squared equals 14 squared. And we could plug negative 9 and negative 6 in, or we can use the Desmos graphing calculator that you'll have on the SOL. So I'm going to go into Desmos and I'm going to type the equation of our circle in. X minus 5 squared plus y plus 6 squared equals 14 squared. If I minimize this and this, I can see my circle a little better, and I'm going to zoom out so I see most of the circle. So I'm going to go to where negative 9, and I'm going to go down to about 6, and I'm going to click on the graph and see how it lights up and says negative 9, negative 6. That's a point on the circle. And if you wanted to, you could see it'll tell you all the points around the circle as you go around. But the one we're worried about, negative 9, negative 6, is right there. So yes, it's on the circle.
Now let's look at some measurements within the circle. Finding angles in the circle are all based on where the vertex is, and the vertex is like the pointy part of the circle. So if the pointy part is on the center, then the angle is equal to the arc. So if this is 68, this is 68. If the vertex is on the circle, then it's equal to half the arc. So if this is 68, then this angle is 34. If the angle is outside the circle, it's going to be half of the bigger arc minus the little arc, so the parts that are inside the angle. If they intersect inside the circle, but not on the center, it's going to be half of the big arc plus the little arc. That would give us this angle in here. So let's try it. Find the measure of JKM. So JKM. That's what we want to know. To find that angle, we need to know this arc. And this is the only measurement we're given. So if I know JLM is 28, that means this arc out here, if I multiply it by 2, it has to be double it, would be 56. If out here is 56, then in here is 28, which means this angle is 28 degrees. In the second one, I'm looking for an angle that's inside the circle but not on the center. So that would be like this last one here. So it's going to equal half of the big arc, which is 60, plus the little arc, which is 20. And if I type that all in my calculator, I get that the angle is 40 degrees. In the third one, it gives me the angle, and it's an angle where they meet outside the circle. So 38 would equal half of the big arc, which is 180, minus the little arc, which is x. From here, you can either distribute the 1/2 or you can multiply both sides by 2 to get those to cancel out. That gives me 76 equals 180 minus x. So x would have to equal 180 minus 76, which means x is 104 degrees. What about segment lengths? If the segments intersect inside the circle. So the pieces that go with the same line, so x and y. So if this is x and this is y, x times y would have to equal the pieces of the other one. So w and z. So w times z. So let's put that to use in this example here. The two pieces, so 9 and 5, so 9 times 5 would have to equal the other two pieces, so 3 times x. 9 times 5 is 45 equals 3x. Divide both sides by 3. X would equal 15. If they intersect outside the circle, it is the outside times the entire segment is equal to the outside times the entire segment of the other piece. So if this is x outside and y inside, w outside and z inside, it would be x times x plus y, because that's how long the entire thing is, equals w times w plus z to find the entire thing. So in this example, for the x part, it's the entire thing and it's the whole outside thing, so it would be x times x equals the outside, which is 2, times the entire thing, which would be 16 plus 2. This just has numbers, so I can type it in my calculator, and it comes out to 36. X times x is x squared. If I square root both sides, then I get that x equals 6. If all else fails, if it looks equal, it probably is equal. So this piece is equal to this piece. So we can solve. To solve, we're going to add 1 to both sides. X squared equals 25. Square root both sides. We get that x equals 5. Here, if the chords are equal, the arcs are equal. So 2x equals x plus 40. Subtract x. X equals 40. Those are all the examples. Go work on your practice problem.